All right, so we left off right before irrational root theorem. All right, the irrational root theorem is very similar to the complex conjugate theorem. All right, it says if the polynomial p of x has rational coefficients and a plus the square root of b is a 0 of p of x, then a minus the square root of b is also a 0. So remember the conjugate theorem was if you had a plus bi, then a minus bi was also a 0. So it's very similar. So basically i's go in pairs, and also square roots go in pairs. Okay, so example 1 says identify all real roots of 2x cubed minus 9x squared plus 2 equals 0. And my hint is try a fraction first. So if we're doing p over q, your possibilities, factors of 2, so 1 and 2, factors of 2 for the next one. And I told you to try a fraction, so what fraction do you want to try? 1/2, right? So I have 2x cubed, negative 9x squared, no x's, and then a 2. So 2, negative 9, 0, 2. Drop the 2. 1/2 times 2 is 1. Add straight down, you get negative 8. 1/2 times negative 8 is negative 4. Add straight down, you get negative 4. 1/2 times negative 4 is negative 2. Add straight down, you get 0. Okay, that means you've factored into x minus 1/2 times 2x squared minus 8x minus 4. We're trying to find when it's equal to 0. Okay, so we can try to factor. We're going to need to pull out a 2. And sometimes when you have like x minus 1/2 and you pull out a 2 from the other part, sometimes it's nice to just write that as 2x minus 1. So then you have nice integers, right? So you can do that. And then this other part, we can't factor. So x squared minus 4x minus 2, we can't find two numbers that multiply to be negative 2 and add to be negative 4. Okay, so what do we do if we can't factor it? Quadratic formula. So x equals negative b plus or minus b squared minus 4ac all over 2a. So it's 4 plus or minus 16 plus 8, so 24 all over 2. So you get 4 plus or minus, the square root of 24 breaks down into 4 and 6. So square root of 4 is 2. Square root of 6 all over 2. And then the last piece is all of these numbers are divisible by 2. So we divide each one by 2, right? It's like you're bringing the 2 into both pieces. So you get 2 plus or minus square root of 6. Okay, so that means your zeros. The first one was 1/2. The second one was 2 plus the square root of 6. And the last one was 2 minus the square root of 6. So do you see why square roots have to go in pairs? So it's from that quadratic formula. It's because of the plus or minus square root part. Yeah, Andrew?
So what happened when you pulled out that 2?
When I pulled out the 2 here, right here. I just pulled out the 2 just to make my numbers better for the quadratic formula. They're smaller. If you didn't pull out the 2, then you would have to simplify even more with the quadratic formula at the end. You know, we divided by 2 everywhere. You'd probably divide by, I don't know, like 4 or something.
And then you just put that back into the other parentheses?
Yeah, just because the reason I was showing you that, so Andrew's asking about this part right here where I pulled out a 2, and then I put it into the other part. Eventually we're going to talk about writing the factored form of the polynomial. And that would be the more correct way to write the factored form of the polynomial. So you don't see like x minus a fraction, you see 2x minus 1. Okay. All right, so section 7.7 is on operations on functions. So the first few are very easy, and then the last couple are things that you haven't seen before. So we'll talk about those. So addition. So if I have f plus g in parentheses of x. It's kind of weird seeing it that way. I know you've never seen that written that way. But basically that just means take your f of x function and add it to the g of x function. So it's kind of a shorthand of writing that. Same with if you see f minus g in parentheses and then of x. That's the same thing. It's a shorthand of writing f of x minus g of x. Same with multiplication and division. So you might see f times g of x. So it's f of x times g of x. And f over g of x is f of x divided by g of x. And on that one we say where g of x is not equal to 0, because we can't divide by 0. Okay, so these first few should be pretty easy. So number 1 says, given f of x equals 4x squared plus 3x minus 1 and g of x equals 6x plus 2, find each function. So if you're asked to find f plus g in parentheses of x, remember that's just f of x plus g of x. So your f of x function was 4x squared plus 3x minus 1, and your g of x function was 6x plus 2. So you have the two functions, the first one and the second one. So you just combine, just like normal polynomials, just combine. I only have one thing that has x squared, so 4x squared. I have 3x and 6x, so I combine those to get 9x. And I have negative 1 and plus 2, so I get plus 1. And that's it. You don't have to try to like factor or anything. Some people think at the end you have to try to factor. Just add your polynomials together. All right, so the next one. So I have f minus g of x, so I have f of x minus g of x. So you have your 4x squared plus 3x minus 1 minus the second polynomial, 6x plus 2. So I wrote the second one in parentheses, so I know I'm subtracting out the entire thing. You could write the first one in parentheses too, it doesn't matter. So when you do that, you get 4x squared plus 3x minus 1 minus 6x minus 2. So you have 4x squared, and you have 3x minus 6x, so negative 3x. And you have negative 1 minus 2, so you get minus 3. All right, so next one, so f times g of 1. Yep, if it was 6x minus 2, then you distribute the negative and make it negative 6x plus 2. Yeah. All right, so compute f of g of 1. So you can do this a couple different ways. You could multiply f times g, like your two functions together, and then plug in 1. But the easiest thing to do is find what f of 1 is and multiply by g of 1. Right, f of 1 times g of 1. Do you see what I'm saying? Like you could find f of x times g of x and then plug in 1 after you multiply your polynomials. So it would look like, I forget what this is, 4x squared plus 3x minus 1. So you remember how you multiply those two polynomials? So you take your 4x squared and you multiply it to both things, take the 3x, multiply to both things, negative 1, multiply to both things. So you get this big long polynomial, and then you can plug in 1. See how that would be hard? Okay, it's much easier if you have a number, just to plug the number into each piece and then multiply. Okay, so f of 1. So I had 4x squared plus 3x minus 1. So if I'm finding f of 1, I just plug 1 in for x. So I get 1 squared is 1 times 4, so 4, plus 3 minus 1, so 7 minus 1 is 6. So f of 1 is 6. And then do the same thing for g. So g of x is 6x plus 2. So g of 1 is 6 times 1 plus 2. So 6 plus 2 is 8. So you just get 6 times 8. So it's 48. And that's your answer. You like this section? Yeah, easy so far. All right, so if I have f times g of x, so that's just f of x times g of x. So this time we don't have a number. It's not like f of 1 times g of 1 like the last one. So we still have x's. So we're going to have our 6x squared minus x minus 12 multiplied by 2x minus 3. So just like last semester when we multiplied polynomials. So I'm going to take 6x squared and I'm going to multiply it into both things over here. So I get 6x squared times 2x is 12x cubed. 6x squared times negative 3 is negative 18x squared. And then I take my negative x and I multiply it by both things on the right side. So negative x times 2x is negative 2x squared. Negative x times negative 3 is plus 3x. And then I take my negative 12 and multiply it by both things. So negative 12 times positive 2x is negative 24x. Negative 12 times negative 3 is plus 36. And then we just combine our like terms. So I only had one thing that had x cubed, so 12x cubed. I have two pieces that have x squared, so negative 18x squared minus 2x squared is negative 20x squared. I have 3x minus 24x, so that's negative 21x, and then plus 36. That's it. Okay, the next one is f of x divided by g of x. So f of x is 6x squared minus x minus 12. And g of x is 2x minus 3. And you know how if you're like dividing like 40 divided by 15, you have to reduce. So if I had like 40 over 15, I would divide each piece by 5, and I'd reduce it down. Same thing with polynomials. So you want to see if they have factors in common. So basically you want to factor the top and see if it cancels with the 2x minus 3 below. So let's try 2x and 3x. I'm guessing minus 3. If it was going to factor, it's going to be minus 3. Or if it's going to cancel, it's going to be minus 3. So I'd need a plus 4. So let's see if the outer and inner work. So your first terms make the 6x squared, and your last terms make the negative 12. Do your outer and inner combine to be negative x? Yeah, you have 8x and you have negative 9x. So those add to be negative 1x. Okay, so that means you have a 2x minus 3 on the top and the bottom. So we just cancel it out. So your answer is 3x plus 4. Okay, that won't always happen, but always look to see if it will. Okay. Do you guys have a red box or a box on yours too? Okay, let me see what it was supposed to be. All right. Okay, we haven't talked about this little O symbol. It looks like fog. Okay, so this is called the composition of functions. So composition of functions, f and g, is written as FOG. So that's like a kind of like a multiplication sign, but it's not. It's like an open circle, and it's real little. So f of g of x, like that. This is the way I prefer to write it, because I think it makes more sense to you guys. It's f of g of x. So instead of having x for your f value, like instead of having f of x, you plug in g of x into f. It's very confusing. So we're going to do some examples. So when you see f of g of x, like fog, like with a little o, rewrite it as f of g of x. So that little o means of. F of g of x. And then you start from the inside and you work your way out. So start inside, work out. Okay, well, g of x is x squared. So I replace g of x with x squared, what it's equal to. So if I asked you guys what f of 5 was, what would you guys do with the 5? You'd go to your f function and you'd replace x with 5, right? Okay, same thing here. So if I have f of x squared, I'm going to go to my f function, and wherever I had x before, I'm going to replace it with x squared. So I'm going to get 2 times x squared minus 3. So it's just 2x squared minus 3. And that's it. Okay, so you may not always see the little o symbol, like g of f of x. I wrote it with parentheses this time. You might see it either way. So let's see if we can do this direction. They aren't the same thing. F of g of x is not the same as g of f of x. So if I have g of f of x, start from the inside. F of x is 2x minus 3. So think about what that means. If you had g of 7, you'd go to your g function, you'd plug in 7 for the x value. We don't have g of 7, we have g of 2x minus 3. So that means instead of having x, I'm going to replace x with 2x minus 3. So I usually put it in parentheses. So 2x minus 3 was your x, and it's being squared. So this replaces x. So you can leave it like that if you want, or you can multiply out. 2x minus 3 squared is 2x minus 3 times itself. So if you FOIL it out, your first terms make 4x squared. Your outer term makes negative 6x, and your inner term also makes negative 6x. So if you combine those two, you get negative 12x, and then plus 9. Yes? You could leave it like this as well. I would accept that as well. All right, so now let's do the ones with numbers, so we don't have of x anymore. All right, so again, we're going to start from the inside and work our way out. So the inside part is g of negative 1. So do we know how to find g of negative 1? Yeah, so if you want to do this off to the side, you can. G of negative 1. G of negative 1, you go to your g function, you replace x with negative 1. Whenever I have a negative, I definitely put it in parentheses. So I have negative 1 is being squared. So g of negative 1 is 1. So that means I have f of, well, g of negative 1 was 1. So f of 1. And now you guys know how to find f of 1, so what's f of 1? Negative 1, right? You plug it in. So you'd have 2 times negative 1 minus 3, so you get negative 1. You just go to your f function and plug in 1. All right, you guys want to try D? Try D, see what you get. All right, so on D, I never really liked the little of symbol, so I always write it as g of f of 2. So so the inside part is f of 2. So if you need to go off to the side and find what f of 2 is, f of 2 is 2 times 2 minus 3. So you get 1. So that means you have g of 1. G of 1 is 1 squared, which is just 1. So you should get 1. And then E is f of 3. So you have so you need to find what f of 3 is. So f of x was 2x minus 3, so it's 2 times 3 minus 3. So you have 6 minus 3, which is 3. So you have f of 3. So f of 3 we just found was 3. So this one's cool because this is called a recursive function. So basically if I had f of a whole bunch of them of 3, it would always be 3, right? So it works for that number. It's not going to work for every number, but it works for that one.
Can you go back to D?
Go back to D, yeah. Okay, so did you guys get both those answers? So 1 and 3, good. All right, so f of x is x squared minus 1, and g of x is x over 1 minus x. Write each composition of functions. So when I say that, I mean find f of g of x and find g of f of x. You could also find f of x and g of x. You could do that as well, but we'll just do these two. Okay, so f of g of x is going to be f of x over 1 minus x. So what this means is look at the f function and replace x with x over 1 minus x. So in our f function, so over here, instead of having x, I'm going to replace it with x over 1 minus x. Okay, you can leave it like that if you want, or you can multiply it out. It doesn't matter. We'll leave it like that. All right, and then g of f of x. F of x is x squared minus 1. So look at your g function and replace x with x squared minus 1. So I'm going to have x squared minus 1 over 1 minus, and instead of x, I'm replacing it with x squared minus 1. Does that make sense? That one's kind of hard. This was x before, and this was x before, right? X over 1 minus x. So instead of having x, I replaced it with x squared minus 1. And I put this second part in parentheses because I wanted to make sure I subtracted out the whole thing. Okay, this one we can simplify a little bit. So I'd have x squared minus 1. I'm going to have 1 minus x squared plus 1. So it'd be x squared minus 1 over the 1 plus 1 is going to be 2, so 2 minus x squared. And that's our answer. A lot of people think you can cancel the x squareds. Do you guys remember why you can't cancel the x squareds? So from one of our previous chapters, if you have like 3 minus 1 over 2 minus 3, you can't cancel your 3's. You can't say it's equal to negative 1/2 because that's actually equal to 2 over negative 1. That's not negative 1/2. Okay, so you got to be careful. Okay, that's it.